Welcome to Mohan classes. In this video we are going to talk about the quadrilaterals. This is for 9th standard. Let us start. Here, what is a quadrilateral? Quadrilateral means it will have 4 sides, 4 vertex and 4 angles. What are all the examples of a quadrilateral? Rectangle, parallelogram, trapezium, square, rhombus. These are all the examples of a quadrilateral. So, in a parallelogram, opposite sides are equal. Already you would have studied in your previous classes. Opposite sides are equal and the opposite angles are equal. Diagonal of a parallelogram divides it into 2 congruent triangles. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. So these are all the things you would have studied in your previous class. The same properties of a parallelogram will never change. It will be the one and the same only. Here we are going to see the diagonal will bisect a parallelogram into 2 congruent triangles. So let us take ABCD is a parallelogram. Here AC is the diagonal. So AC is the diagonal. AC is the diagonal of a parallelogram. Of the parallelogram ABCD. Okay. So in triangle ACD and triangle ABC, AB is equal to CD. Opposite sides of a parallelogram are equal. And then AD is equal to BC. Same opposite sides of a parallelogram. And then AC is common. Okay. So it satisfies S, triple S. Therefore, triangle ACD is congruent to triangle ABC. So that means AC is a diagonal, divides the parallelogram ABCD into 2 congruent triangles. This is the proof. So here the converse. Suppose if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Here, suppose this each pair of opposite sides are equal. So this is equal and this is equal. Then how we will prove? Same. In these 2 triangles, these 2 are equal and AC is common. Again the same only we have to write. These 2 triangles are congruent, then it is a parallelogram. If in a quadrilateral each pair of opposite angles, so if we prove these 2, how we will prove the last one? So if ACD and ABC, the triangle ACD and ABC are congruent, then we can say angle ADC is equal to angle ABC. So if a quadrilateral each pair of opposite angle is equal, then it is a parallelogram. So if it is a parallelogram, the opposite angles are equal. This we can prove as per CP. Understand? So these are all the properties, but it is not that much, this proof is not that much important, but you should know how to prove the properties of the parallelogram. Okay, let us move to the next. Here, the diagonals of a parallelogram bisect each other. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. So first we have to say the diagonals of a parallelogram bisect each other. or if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. So it is the converse. So for these two, same is the proof. In triangle, let ABCD is the parallelogram, AC and BD are the diagonals, bisects at O. In triangle COD and triangle AOB, what we can say, angle ABO is equal to angle ACD. Angle ABO is equal to angle ACD. Why? Alternate angles. And then angle BAO is equal to angle BAO is equal to angle OCD. This is also alternate angle. And then CD is equal to AB. Opposite sides are equal. So as per this AA, yes. So this triangle COD is congruent to triangle AOB. If these two triangles are congruent, then we can say OA is equal to OC and then OB is equal to OD. So that means this AC and BD bisect each other and OA is equal to OC. Therefore, the diagonals AC and BD bisects each other. Hence the proof. Okay. Now let us move to the next. Here diagonal AC of a parallelogram ABCD bisects angle A so that it bisects C also, and ABCD is a rhombus. Here we have to prove ABCD is a rhombus as well as the diagonal bisects angle A at Z. In triangle ACD and triangle ACB. Let us take triangle. In triangle ACB and triangle ACD. In these two triangles, CD is equal to AB, opposite sides. Opposite sides are equal, and then angle BAC is equal to angle CAD. It is given. And then angle CAD is equal to what? Angle CAD is equal to angle ACB as per alternate angle. Okay. So therefore angle BAC is equal to angle ACB. That means angle ACB is equal to angle BAC is equal to, why it is? Angle BAC is equal to angle CAD, right? As per this, BAC is equal to ACB. Therefore, angle ACB is equal to angle ACD. So, angle ACB is equal to angle ACD means this AC bisects angle C. Therefore, AC bisects angle C also. Okay. Now we have to prove that it is a rhombus. How you will prove it is a rhombus? So this angle is equal to this angle, and these two angles are equal. That means equal. So angle BAC is equal to angle BCA. See, understand? Because angle ACD is equal to angle BAC. Angle BAC is equal to angle ACD. Okay. So what I am saying, this angle BAC is equal to angle ACB. BACD. Sorry, not ACD. 1 minute. Huh? It is not. Angle ACD is equal to angle ACD. This angle is equal to angle BAC. Alternate angles are equal, and this angle is equal to this angle, but these two angles are equal, right? Angle BAC is equal to angle CAD. Therefore, what I am saying, angle BAC is equal to angle BCA. Equal angles, these two angles are equal. Equal angles mean opposite sides are equal. These two sides are equal. If these two sides are, therefore AB is equal to BC. Sides are equal. Sides are equal because of opposite angles are equal. Understand? So if AB is equal to BC, similarly we can prove CD is equal to AD, because BC is equal to AD, opposite sides are equal, right? Therefore BC is equal to AD and AB is equal to CD. All the four sides are equal. Therefore it is a ABCD is a what? Rhombus. Understand? This angle is equal to this angle. Why? Because these two angles are equal. This angle is equal to this angle. Therefore, these two angles are equal. So, the opposite sides are equal. Two angles are equal means the opposite sides are also equal. So, ABC is equal to AD. Therefore, all the four sides are equal. Okay? Then it is a rhombus. Let us move to the next. Here, in a parallelogram ABCD, 2 points P and Q are taken on the diagonal BD such that DP is equal to BQ. We have to prove triangle APD congruent to triangle CQB, and AP is equal to CQ, and triangle AQB congruent to triangle CPD, and AQ is equal to CP. APCQ is a parallelogram. Here it is a 5 things we have to prove. One by one, let us do. In triangle APD and BQC, in triangle APD, not APD, APD and triangle BQC, AD is equal to BC, or BC is equal to AD. Why? Opposite sides of a parallelogram. And then DP is equal to BQ. It is given. DP is equal to BQ, it is given. And then angle CBQ. This angle is equal to this angle. Why? Alternate angle. Angle CBQ is equal to angle PDA. Alternate angle. Okay. Therefore, It satisfies SSA, right? Therefore, triangle APQ, APD, triangle APD congruent to triangle CQ or BQC or CQB, both are same. CQB or BQC. First one is, what is this? SSA. If it is congruent, then we can say AO is equal to AP is equal to CQ. So we have proved 1 and 2, right? Two things we have proved. This we have proved and this also we have proved. Now we have to prove AQB is equal to CPD. So let us take in triangle AQB and CPD. In triangle AQB and CPD, in these two triangles, CD is equal to AB or AB is equal to CD, opposite sides. Opposite sides, and then we can say BQ is equal to DP, it is given. And then we can say this angle is equal to this angle, alternate angle, right? Angle ABQ angle ABQ is equal to angle PDC. So it satisfies SSA. Therefore, triangle AQB congruent to triangle CPD. If these two triangles are congruent, then we can say that AQ is equal to PC. CP by CPCT. You know what is CPCT? Corresponding parts of congruent triangle. So we have proved 4. The last one, APCQ, is a parallelogram. Here now in this quadrilateral APCQ, in quadrilateral APCQ, now we have to say it is a parallelogram. How we are going to say? It is a quadrilateral ACPQ. In quadrilateral ACPQ, PC is equal to AD, we have proved, and similarly AP is equal to QC also we have proved. Therefore, APCQ is a parallelogram. Hence the proof. Okay. Let us move to the next. That's it for the day. If you like this video, kindly share it to your friends, and don't forget to give your likes. Thank you. Here ABCD is a parallelogram and AP and CQ are perpendiculars from vertices A and C on diagonal BD. Show that a triangle APB congruent to CQD and AP is equal to CQ. It's very simple. How you are going to prove that? In triangle APB, in triangle APB and triangle CQD. In these two triangle APB, angle APB is equal to angle CQB. Why? angle APB is equal to angle CQB, because both are perpendicular, it is 90 degree. And then ABP angle ABP is equal to ABP, this angle is equal to this angle. Why? Alternate angle, right? ABP is equal to angle QDC or CPQ, CDQ, right? Alternate angles are equal. Alternate angles are equal. And then what? ABP is equal to CDQ, AB is equal to CD, right? Opposite sides are, so AB is equal to CD. Opposite sides are equal. Therefore, these two triangles satisfy AAS. Therefore, triangle ABP congruent to triangle CQD. ABP is congruent to triangle CQD. This we have proved. After that, if these two triangles are congruent, then we can say AP is equal to QC. By CP, CP. Hence the proof. Okay. Let us move to the next. So it is very, very important theorem. By using this theorem, we have to do so many sums in this chapter. So here the line segment joining the midpoints of two sides of a triangle is parallel to the third side. So E and F are midpoints of the side AB and side AC. So we have to prove EF is parallel to BC, correct? The line segment joining the midpoints of two sides of triangle is parallel to the third side. Parallel to the third side we have to prove. So what we have to prove, that EF is parallel to BC. This we have to prove. And then EF is equal to half BC. This also we have to prove. So let us, what is given? So given ABC is a triangle, E and F are midpoints of a side, AB is equal to AC respectively. Here E and F are midpoints of AB and AC. Therefore, what we will say? AE is equal to PE and AF is equal to CF, right? Because E and F are the midpoints of this. So now, what we have to prove that? To prove that EF parallel to BC and EF is equal to half BC, we have to prove. These 2 points we have to prove, this and this. So, what is the construction? Construction, draw CD, draw a line parallel to AB which bisects this EF at D. Draw line CD. Draw line CD parallel to AB. Draw line CD parallel to AB. It intersects EF at D. It meets EF at D. Okay. Now let us go to the proof. In triangle AEF and CFD in triangle AEF and CFD. In these two triangles, AE is equal to CF, right? Let us take EAF. EAF, this angle is equal to this angle because alternate angle. Let us take first EAF angle. EAF is equal to angle FCD why alternate angle. And then AF is equal to FC. AF is equal to CF or FC because F is the midpoint of this. And then similarly we can say what? Angle AFE is equal to AFE. This angle is equal to this angle. Why? Vertically opposite angle. Angle AFE is equal to angle CFD. Vertically opposite angle. Clear? So what we did, EAF is equal to FCD alternate angle, AF is equal to FC, it is given because F is the midpoint. AFE is equal to CFD as vertically opposite. These two triangles are congruent. Therefore, triangle AEF congruent to triangle CFD. If these two triangles are congruent, then we can prove that EF is equal to DF. EF is equal to DF by CPCT, and then AE is equal to CD. Yeah. Sorry. AE is equal to CD. This is also by CP. AE is equal to CD. And then therefore BCDE is a parallelogram. Therefore BCDE is a parallelogram. Therefore BCDE is a parallelogram. If BCD is a parallelogram, it means ED parallel to BC, right? ED parallel to BC, that means EF parallel to BC. Clear? What is EF? What is EF plus DF? EF plus DF is equal to BC, right? BC is equal to EF. We are saying if this is a parallelogram, ED is equal to BC. What is ED? EF plus FD is equal to BC. EF is equal to FD, these two are equal, right? As per this, EF is equal to FD. Therefore, I am going to write 2EF is equal to BC. It is BC. Therefore, EF is equal to half BC. Clear? This we have proved and this we have proved. Hence the proof. Here it is very, very important. Please try to understand what we did here first. First we have drawn CD parallel to AB, which bisects the EF at D. Now we have taken these two triangles. We have proved these two triangles are congruent. Then AE is equal to CD. AF is equal to AF is equal to CF. So these two triangles are congruent. We have proved. After that, we have proved AE is equal to CD. And then we have proved BCD is a parallelogram. BCD is a parallelogram means BC is equal to ED. ED parallel to BC, therefore EF parallel to BC we have proved. After that, ED is equal to BC because opposite sides of a parallelogram. Therefore, ED can be written as EF plus FD. So, half of EF is equal to, 2EF is equal to BC, EF is equal to half of BC. Clear? The converse. Converse also we can do the same thing. Suppose if EF parallel to BC, we have to prove E and F are the midpoints of what? AB and CD. That is the converse. The same only we have to prove. Let us move to the last one. So here in a parallelogram ABCD, E and F are the midpoints of side AB and CD respectively. Show that the line segments AF and EC trisect. So that means here what we have to prove, BD trisected. DP is equal to PQ is equal to DP. What we have to prove that? We have to prove that DP is equal to PQ is equal to QB. This is the thing what we have to prove, that is trisect the diagonal BD. Okay, let us take AB parallel to CD. Okay, that is AB is equal to CD because ABCD is a parallelogram. AB parallel to CD and AB is equal to CD. I am going to take divided by 2, half AB is equal to half CD. So that means AF half AB is equal to half CD. So that means what? AE is equal to half CD. AE is equal to FC. Why? E and F are midpoints. E and F are midpoints. Okay, E and F are midpoints, therefore AE is equal to FC. And then AECF, AE in quadrilateral AECF. In AECF, AE parallel to CF and AE is equal to CF. Therefore, AECF is a parallelogram. Okay, we are saying AE parallel to CF and AE is equal to FC because of E and F are midpoints. So this is a parallelogram. If AF, now let us take AF parallel to FC, opposite sides of a parallelogram, because if AEFC is a parallelogram, then AF parallel to BC, right? We have proved AECF is a parallelogram, therefore AF parallel to FC, the AF parallel to EC, AF parallel to EC, opposite sides are parallel, right? So in DQC, let us take DQC in this triangle DQC. In triangle DQC, P is the midpoint, F is the midpoint of CD, right? F is the midpoint of CD and FP parallel to QC, because F is the midpoint, the line joining FP parallel to EC or QC. Therefore, what we are going to say, FP parallel to CQ. FP parallel to CQ. Why? Because F is the midpoint, the line joining the midpoint, the line passing through the midpoint of CD will be parallel to CQ. That is the theorem. So that means P is the midpoint of DQ. Midpoint of DQ. So that means dP is equal to PQ. Clear? You keep it as 1. Similarly, in triangle APB, this triangle you will take. In triangle APB, the same. E is the midpoint of AB, right? E is the midpoint of AB, midpoint of AB. Therefore, EQ parallel to AP. That is the theorem. So that means Q is the midpoint of PB. Clear? So if Q is the midpoint of PB means PQ is equal to QB. From 1 and 2, here dP is equal to PQ. PQ is equal to QB. Therefore, from 1 and 2, dP is equal to PQ and PQ is equal to QB. So that means EC trisect the diagonal BD. Therefore, what we are saying, AF and FC trisect the diagonal, hence the group. Okay, it's very simple. First we have taken this triangle. In this triangle, F is the midpoint, therefore FP parallel to this P is also the midpoint of PQ, therefore DP is equal to PQ. Then we have taken APB, this triangle, here E is the midpoint, EQ parallel to AP and Q will be also the midpoint, therefore PQ is equal to DQ. So this AF and FC trisect the diagonal BD. That's it. That's it for the day. If you like this video, kindly share it to your friends. Don't forget to give your subscribe. Thank you.